So different nucleophiles can behave differently when they react with things like alpha beta unsaturated ketones. So let's look at nucleophiles and the idea of doing 1,4 versus 1,2 additions. Okay, so in general, if you want to do a 1,2 addition to an alpha beta unsaturated ketone, and let's just draw one up here. If you want to do a 1,2 addition, you want to use things like Grignards, organolithiums, let's see, acetylides, that's deprotonated alkynes, and most enolates. Note that these are really strong nucleophiles. They're highly reactive. Okay, so we're setting up a contrast. What if I want to do a 1,4 addition? What kind of nucleophiles will do a 1,4 addition? Well, they tend to be less nucleophilic things. Amines, the nitrogens of amines are great for these reactions. Sulfides, which actually go all the way back to the early days of SN2 chemistry. We said they're great SN2 nucleophiles. They're also great nucleophiles for 1,4 additions. And then stabilized enolates. Okay, this is a little confusing because on the left we have most enolates, and then on the right we picked out stable enolates. So we have to distinguish these. What are most enolates? When I say a typical enolate, like most enolates, think of something like acetone. Acetone gets deprotonated, makes an enolate, and this is a typical enolate. Most of the enolates we encounter are simply ketones that have been deprotonated. So this is a typical enolate. Now, when I look at an enolate, I kind of look at it as this carbonyl group acts as an electron-withdrawing group. So with electron withdrawing through resonance. But an enolate is an anion that bears one electron withdrawing group. So most enolates have one electron withdrawing group on the anion. Let's go to stable enolates. Stable enolates might look like this. So a stable enolate, we have an alpha carbon that's sandwiched between two carbonyls. And so when we form an anion here, it's an enolate, but it's very stable. Well, why is it so stable? It has to do with these two carbonyls. It's flanked by one electron withdrawing group on one side and another electron withdrawing group on the other. So stabilized enolates have two electron withdrawing groups. And as we know, electron withdrawing groups aren't only carbonyls. Think of your meta-directors in electrophilic aromatic substitutions. What do we see as meta-directors? Well, certainly carbonyls. But your electron withdrawing groups can be things like cyano groups or nitro groups as well. And so there are a lot of ways, different ways to put together a stabilized enolate. You know, up here we could say this would form a stabilized enolate because we have both the nitrile electron withdrawing group and the nitro electron withdrawing group. So the anion between those would be very, very happy indeed and a very stable anion. And that's what we tend to see in the 1,4 addition. Not on the left, these strong nucleophiles, highly reactive, but these are weaker nucleophiles. Hey, don't get me wrong, they're still nucleophiles. And they're a little bit less reactive. So those are the kinds of nucleophiles and the products they lead to when you encounter things like an alpha beta unsaturated carbonyl as your electrophile.